Here we are. We have a request to do a video of an acetoacetic ester synthesis or a malonic ester synthesis. And here is a summary of the targets you would see for an acetoacetic ester synthesis. You can clearly see acetone circled here. Acetone is an indicator of an acetoacetic ester synthesis target molecule, and you're going to be putting these two new R groups on there. So to make this a generic handout, I'll make this R, and that covers everything on this page now. If R is a methyl, that's a ketone, and it's part of an acetoacetic ester synthesis. If R is an OH, it's a carboxylic acid, specifically a disubstituted acetic acid, as we would have here if this was OH, with two new R groups. Or an acid halide if this was such as a halogen, or an acid anhydride if this was such as a carboxylate, or an ester if this was an OCH3 or OR in general. This is the exact target molecule from Fall 21, Test 2, Part 4, and that's the one we're going to be doing the retrosynthetic analysis of on the next page. If R is a nitrogen, then we have an amide, and that would also be a potential target molecule. Moving along. Here is our Fall 21 Test 2 Part 4. Once you've established that you want to use the acetoacetic ester synthesis, and you did so by realizing that right in here is a derivative of acetic acid. So you want to be doing a malonic ester synthesis as indicated in previous videos. So what do we have before we have our target molecule? Well, we have the actual acetic acid. With our two new R groups. Well, they're not new. They will be when we do the synthesis. There we go. And what do you react a carboxylic acid with to make an ester? None other than an alcohol. And we'll be doing the forward synthesis at the end. The purpose of this video is to do it in the proper retrosynthetic analysis technique. I was told the previous version of this video was confusing. So this is the end of the carbons for this segment of the target. Now we have to talk about what is in a malonic ester synthesis. Well, this is our new target, and it used to have two carboxylic acids before it was this target. Two carboxylic acids on the same position. And I don't want to draw my R groups more than I have to. So everything here, R prime, and this homobenzylic group are double prime. So we have R prime and R double prime attached to a carbon that had two carboxylic acids. How do you get rid of the second carboxylic acid? Well, I'm not going to start my rap song just yet until we get into the forward synthesis. Look at that. This is malonic acid with two new R groups on it. Surprised? I hope not. Okay, as the name implies, a malonic ester synthesis doesn't come from a malonic acid. It comes from a malonic ester. And in this case, it better be a diester, because we do not want acidic protons getting in the way of doing our synthesis. So both of these used to be CO2 ET. Doesn't have to be ET, it does have to be an ester. And here we go. We are now wrapping around over here. Here's the beauty of the malonic ester synthesis. We know how to make each of these bonds to our new groups, such as this bond. That would be R prime attached to a leaving group, such as Cl, and R double prime attached to our new target. And for this to be making new bonds, it has to be a nucleophile. And where does this nucleophile come from? Yeah. Comes from the conjugate acid with a pKa of 10. So that wasn't an anion just yet. Yes, we'll get our retro arrow pointing upwards here. And it used to have an H there, an easily accessible H. And the beauty of the malonic ester synthesis is revealed again. How do we get that other R group on? Well, we take that H off. Oh, we forgot to say what this reacted with. Oh, we did. I'm sorry. We have that. Okay. Where'd this come from? It came from its conjugate acid. What was it before this? Well, it was R double prime with a halogen on it. This would be the second synthetic step in your retrosynthetic analysis. And we have this species here. Let's not do it that way. And that also came from its conjugate base. Conjugate base up here. Sorry, that is the conjugate base. I misspoke. Comes from its conjugate acid. With this easily accessible hydrogen with a pKa of 10. And where does that come from? Well, malonic esters come from malonic acid, as do all esters come from their parent acid. Trying to move this molecule a little. I have a feeling, I was lucky. Here we go. And I have my retro arrow lurking here. Oh, it's going to give me trouble. I know it. Yeah. So, malonic acid. Okay. Is right here. Oops, not there. There's malonic acid. Don't need a radical here. Malonic acid. Acid. Here we are. You're not done yet. You're not allowed to start with malonic acid. Malonic acid is not listed in the ingredients in part A. Once again, this was a typo that I'll have to fix for your test because I always start these tests by copy pasting the old one. And this should be changed to 5 carbons or less. Don't have to erase everything, Dr. Whitaker. Just the 3. We have a 5. And there's a 3 carbon diacid right there. And what did it react with to make the ester below it? HOET. Yes, our second Fischer esterification in the same synthesis. All right, and where do all carboxylic acids come from if we're restricted to items on our list? And I don't see my mouse, so I see it now. All carboxylic acids can come from alcohols, which are on our list. HO, CH2 once, twice, 3 times, OH. And where do acid halides come from? R prime Cl is here. And it's a 5-carbon unit. If you look carefully, 1, 2, 3, 4, 5. So you are one step away from done on that one. That came from R prime OH. Circle it. 5-carbon alcohol is on your list. Where did our double prime Cl come from? Came from another alcohol, but it's not on the list. No problem. We'll work on that when we can. If that is the molecule, then it has right here on the carbon 2 carbons away from a phenyl and OH. That is not benzylic alcohol like we're allowed to start with. It's homobenzylic alcohol. But we've had experience extending alcohol's length on our previous exam, and we should not be shocked to be having to do it again. Our double prime minus plus formaldehyde. Oh, not even our double prime minus, my mistake there. There's your extra carbon. It's not our double prime anymore then, is it? We need phenyl CH2 with a nucleophilic character. Phenyl, that's not a phenyl. Phenyl CH2 lithium is a nucleophile. And we're going to take formaldehyde back to methanol and circle it. And here's our circle. And where do organolithiums come from? Of course, I painted myself into a corner here and I'm almost out of room. Didn't stop me before I did it. Where do benzolithiums come from? They come from benzyl halogens. It's the only place they come from. Cl, Br, doesn't matter. And that comes from benzyl alcohol, which we may circle. And I'm going to circle it. Going to big screen it. So we have the whole thing. And we're going to stop the video and come back and do another video where we do the forward synthesis. Giving it a shot.